7.4. Adding and subtracting rational expressions with binomial and trinomial denominators. Ah! What? That is such a long title. It took me a really long time to write it. Just like it's going to take us a little while to really fully wrap our minds around this topic. It's not super scary. It's kind of just like the next logical step to what we were doing in 7.3. But, yep, it's a little bit more complicated. What I want to do first, just go through a whole bunch of different examples and just find the lowest common denominator. That's it. This is something that looks pretty common. The lowest common denominator between these two things would just be b squared, right? That's it. And if we were doing non-permissible values, we would say b cannot equal 0. What about this one? It already has a common denominator. So it's like saying 5 over b plus 5 over b is 5 over b plus 5 over b is just 10 over b. Okay? But we don't have that. We have a, what is it? We have a binomial. We have two terms. So the lowest common denominator is going to be x plus 3. And x cannot equal negative 3. Because if x equals negative 3, that would bring both of these denominators to what? 0, and that's undefined. I'm going to go through this pretty quick, but this and this are kind of related, right? We have a factor and a factor squared. What would the lowest common denominator be? It would be b squared. So what do you think that the lowest common denominator between x plus 3 and x plus 3 squared would be? Using this model right here, we would just say the lowest common denominator is just x plus 3 in brackets squared, where x cannot equal negative 3. Okay, so it's just kind of logically extending what we've already been doing. What about this one? The lowest common denominator between x plus 3 and x plus 5. Well, if I would have, say, something like a denominator of 4 and a denominator of 3, all I would do is multiply those two things together, right? Well, guess what, folks? We're going to do the exact same thing. The lowest common denominator is x plus 3 and x minus 5. What I don't want to do is I don't want to expand this, because this makes it really nice later on so that we can cancel all the factors of x plus 3 or x minus 5. Don't forget your non-permissible values. X cannot equal negative 3 or it cannot equal positive 5. Next one's a little bit trickier because we need to do some factoring first. So I'm just gonna section this one off actually. Okay? So what we would do is we would say, okay, well then this is just 3 over x plus 3 squared, right? This is a perfect square trinomial. By now we should know that just by looking at it. Why? Because it's 3 squared and 3 times 2 minus 2 over x plus 3. Looking at this, very similar to this one right here. The only thing that's different about this is that we had to factor it. Okay, you have to sometimes do that step of factoring. So we're going to say our lowest common denominator is x plus 3 squared. Okay, x cannot equal negative 3. We have to do the same thing with this last one. What do we notice about this? Ah, yes, it's a difference of squares. So let's first factor it. I'm just going to keep on working this way. So we have 5 over x plus 3 plus 2 over x plus 3, x minus 3, because that's what this is factored. So our lowest common denominator is going to be our x plus 3 times x minus 3. Hopefully you can see that. Ooh, maybe not. Sorry, lowest common denominator, x plus 3, x minus 3. X cannot equal plus or minus 3. This right here is just the baby step beginning blocks for the questions, but if you understand this, this is kind of the toughest part.